So this is about how light bulbs work. So light bulbs have a simple structure. They have two metal contacts that connect to the end of the wire. Basically, that means that there's going to be two wires, one, two, and there's going to be filament that goes around the outside of the light bulb and goes back inside. And guess what happens when electricity goes through this wire or tungsten? It heats up. Why? Because unlike a traditional wire, most electrical wires include copper because they have the least heat dissipation. Basically, what that means is that when electricity is traveling through something, there's going to be heat generated because when electricity travels through something, it's kind of like water. There's too much pressure. Let's say there's a plastic, just the same diameter. So let's say there's a 5 diameter tube made of plastic, and then another 5 diameter tube made of titanium. And each of them have water, like all the water, and have water. All the water through the California Dam is traveling through like that tube, that 5 millimeter or 5 millimeter diameter tube. Which one do you think is going to break faster? The plastic one, of course. Why? Because the plastic is not strong. Same applies to this. Copper is like titanium. Plastic is like tungsten. Plastic will break easily. The same with tungsten. It breaks easily, but at the same time, with tungsten, it breaks over time. The more electricity travels through it, the longer the quicker its lifespan. For example, since since titanium will obviously take longer to break, there isn't much, I don't know, seepage. Or you know how if you break something or put your arm or punch glass, it breaks, right? What if you punch your arm on metal? It doesn't break. What if you punch it 100 times? It might break slightly. The same thing with this. Tungsten is like glass. It will break easily, but not as quickly as glass. Let's say that you've on and off the switch about 1 year, for about a year, and turn it on, turn it off, turn it on, turn it off. What happens is that as more electricity passes through this, heat gets made because tungsten is not a good conductor for electricity, meaning that as electricity travels through this, heat gets generated more than copper. Copper only has a heat generation of about 2%, while something like this has a heat level of like 90 to 95%. So basically, there's two wires. This wire is the electricity, and this is for over electricity or too much electricity. As electricity flows through this, it gets connected as heat. And when you have too much heat on a very small place, like for example, this wire is capable of producing light or heat enough to power your whole room. This is because this thin wire is going to connect all that electricity into heat. When there's too much heat in a small space, like this glass bulb, enough to power a whole room with light, all that heat gets converted into light. Since all that heat is being converted into light, kind of like the sun. Since it's so hot, all that heat is being converted into light, so on and so forth. So electrical currents flow from one contact to each other. This is for overflowing electricity. And like I said, a more advanced example would be as atoms travel through the filament, this causes the atoms to vibrate, causing heat, kind of like tungsten. In other words, heat is generated and this is converted to light energy.